So I'm really excited that Brian is here today to help you upskill in this critical skill so that you can add it to your portfolio, so you can speak about it in your upcoming interviews. And with that, I'm going to go ahead and mute myself and turn it over to Brian. Thank you so much.
Hey, everyone. So yeah, thanks for having me here. Really excited to kind of get into this. I'm going to do a little bit of a presentation kind of talking about unit testing in general. And then we're going to get into an actual code sandbox that I've created to go over really basic jest, like setting up a jest test, kind of what the format and anatomy of a test is, and then a React testing library test. And just out of like curiosity, show of hands or in the comments, like who's never written a test before? You can just like, yeah, you can use those little hand emoji things if you want, reactions. Okay, cool. Seems like got a few hands in here. I kind of expect that. I actually went through like the first few years of my career not writing a single test at all. And then like many of you probably that are going to come into a job or already working, you're going to find that tests are kind of this silent expectation. Like no one really ever teaches you it. They just kind of say, oh, you can't get your PR, your code reviewed without having a test associated with it. And then you spend a ton of time like figuring out how to write a test and then actually doing it on the job. It could be stressful. I know for me, it certainly was. And now I've kind of gone from zero to like bringing it to Clorox, the company I currently work at. I'm going to get into the presentation, but I also want to make sure if you have questions, feel free to ask them through the chat. This will be fairly interactive through the last portion of it, where we'll, hopefully all get access to this code sandbox and you can follow along and maybe use it to, do your own tests for this React code we're going to check out later. And now I'm just going to start sharing my screen. Got to, of course, ask. Always got to ask. People can see it, right? Have to ask that question.
I can see Brian.
Good. All good to go. Let's do this. All right. From zero to testing at scale. So we're going to go for some myths about unit testing, how the team that I currently work on adopted a culture of testing, and then testing what's important and kind of just the whole anatomy of why you want to write tests, discovering some of the myths around it, and seeing like how this can improve you as a developer and your team. So who am I off the bat? I'm Brian. I'm an engineering manager at Clorox, the company that many of you are probably familiar with. And you probably think, why do they have a tech team? What do the engineers at Clorox do exactly? Well, Clorox has websites that we sell e-commerce merchandise, right? So I've worked at startups. They were like small startups in San Francisco, other places around the Bay Area. And then I got into Clorox, and I learned actually that e-commerce is, obviously huge. It exploded during the pandemic. And I was one of the first kind of front end senior people they brought on here to help lead them in this transformation into the digital space. So what my team works on mainly is React front ends, as well as a series of microservices that we've retired, but we basically do full stack JavaScript work on sites like Burt's Bees, Berta.com, and Clorox.com currently. Looks like I got something in the chat, just making sure. Yes, cool. Let's see here. And you're not writing tests. I know a lot of you are not. So in 2020, I joined this company, Clorox, and I thought, oh, it's a huge company, right? They must have tons of tests. They must have a really sophisticated testing strategy or something like that. They're a Fortune 100 company, actually. They have all these production e-commerce apps that many of you probably go to, thousands of lines of code. They had 0 tests at first on the front end. And I was kind of shocked at this. And then we had to dig into why. That was my first things as a senior engineer. When I joined there, I thought, why are we not writing any tests at all? I'd come from a place where I worked with a ton of engineers, and we had test coverage really, really high, which I don't think is actually necessary. But I was used to this culture of writing tons of tests. So some of the myths about writing tests, I'm just curious if people have heard, if you have an excuse or a reason why you haven't started writing tests, if you've heard some, drop them in the comments. I'm curious to hear what other people have heard for the excuses for why you shouldn't write tests. I've heard it all. When I first came there, they thought, well, we can't write tests until we get to TDD. They take way too long to write. We just don't have time. We have a deadline we have to hit. There's simply no time to write tests. Then they say, wait, we have QA team too. Can't they just do that? And then people said, well, what's the point of writing the tests if we don't get to, some arbitrary number of test coverage? We need a ton of test coverage, kind of going back again towards time. Or my favorite excuse, we'll add them in later. Once we're all done, once we're in a good spot, we'll add them in later. That later time never, ever happens. I've never seen that happen on a team. So why do we write tests? How do we address some of these myths? Tests are not to replace a QA team. You don't have to follow TDD, even though I know that's like all the rage. If you go on Twitter or LinkedIn, you'll see a bunch of TDD experts that claim that everybody's using TDD. I'll be honest, I've worked at several software teams, and I've seen about 2 people in my entire career that were actually using TDD. I don't think there's anything wrong with it, and I don't think there's anything wrong with writing tests after you write your code. What tests should do is enable refactoring. It's really difficult when you step into some code and you say, I want to change something. And this code could be really complex. And you say, I want to change something, but then you don't know if what you've changed actually works as it's intended to. So writing tests helps you refactor pretty ruthlessly, because now you can see, hey, did I actually change the functionality of this, or is it the same and now it still works? Now this test gives you that additional confidence that what you've done hasn't broken old behavior. It also confirms expected behavior. I was on a team years ago when I first started writing code, and we had a really complex scenario in this app that I was working on. And I changed one line of code. We had to test 12 or more scenarios, like a dozen scenarios. And we had to do this every single time I changed a piece of code. I said, well, that didn't work. Let me try something else. Well, that didn't work. Let me try something else. So we were literally spending hours doing this manual QA every time I made a small change. You can imagine how frustrating that is. At the time, I didn't even know much about unit tests. This was almost 10 years ago when it wasn't so much the rage. And then after that, I said, there's got to be a better way. And then I see this is one of the benefits of writing tests. They allow you to move a lot faster as a developer. They also act as documentation for other developers. How many times have you gone into a code base and you see something that's complicated and you think, I don't really know how that works. And then you're afraid to touch it. And when you're afraid to touch things, you just kind of let them rot and you say, I don't know how to touch that. And then the person that made it leaves the company. Next thing you know, it blows up and you're all screwed. So writing tests is good documentation, helps other developers get into the weeds and understand, oh, this is what's supposed to happen when a user clicks this button, for example. Also mimicking hard to test edge cases. A lot of times you might make a request to an API. The API returns, what you expect. But how do you test when it doesn't? How do you test when things break in these weird edge cases that aren't so easy to replicate manually? This is when tests can really come in handy. So the hardest test to write, and the test writing is not, I like tests. I find a lot of value in them, but I also know they're not easy to write. The first test you need to write is the hardest one. And that's because once you write this test, it typically involves a lot of scaffolding, of like adding libraries, and just kind of figuring out like what are you going to test? How are you going to do it? That first test is always going to be the most difficult one, but it's usually the one that's going to pay the most dividends, because once you write the first test, the next and the next and the next become progressively easier, because you'll soon discover when you write tests for something like a React component or a unit test, for example, that a lot of that same logic can be reused. For example, if you have a React component that uses Redux or fetches some data from an API, once you figure out that difficult scenario, you can apply that to many, many different scenarios. And my favorite thing, I say this to my team, to go really fast, sometimes you got to go slow at first. You have to have that initial runway to go a little slow. And then you can have that hockey stick like curve where your progress really shoots up. And this is when I started working at Clorox, one of the first things I had to do was change our checkout flow. We have an e-commerce app with a super complicated checkout flow. No one really knew how it worked. There was no documentation on it at all. And we had a very aggressive deadline to hit. And I was in charge of refactoring this checkout flow. The first thing I did before I wrote any code was to write a test that went through every single scenario I could see, and then make sure that what I did after didn't break anything. This helped out tremendously. And this is kind of how I sold testing to the team, to the VP, and got the team more involved and invested in testing. This test was incredibly complicated to write. I was under a lot of pressure, but then it paved the way for us to write tests now. And we've gone from 0 to about 40% coverage across all of our applications since the time I've joined the company. Scaling the tests, tests are great. This goes in a little bit more of like the architecture behind our testing at many software teams. This is kind of your typical architecture. You write one test that snowballs into more tests, ideally, where you say, okay, yeah, first test, you build upon those tests, right? You say, oh, this is kind of like that test. I'll copy paste some code from there and keep building upon these tests. And then to make sure that developers don't just say, you know what, I'm not going to write a test, because it's much easier to not write tests, right? It's not always like the first thing we want to do. We're not like, oh, great, I have a deadline and I wrote the code. Now I just want to write a test. People will try to circumvent writing tests, especially when they're not used to it. So one thing I had to do on the team was have a check in a Bitbucket pipeline. So the code would go from your local machine, you'd check it into Bitbucket, for example, or maybe GitHub, and then would run a script that would then check to say, hey, are there certain amount of tests, or is there a certain percentage of coverage that's being hit? For example, if I said there's going to be 50% coverage, that we're checking that 50% of all files or 50% of all lines of code have tests associated with them. If somebody added a new file, for example, and there were no tests, the pipeline would break and they'd be forced to go back and write the test. After it passed, then it would get deployed to AWS or some other cloud provider, and then it would be out there in the wild. And that's kind of like, one, introduced testing, and then two, enforced it at scale across my team and now other teams that we work with as well. So let's actually write a test. So we're gonna I'm gonna go through some tests that I wrote. Now I'm gonna drop this also in the comments, but let's check this out. You can follow along within here, and I want to also look at the comments if I can to make sure people can access this. I'm putting this in the comments here. This is using Code Sandbox. I like using Code Sandbox because it's really easy to quickly scaffold an app, and that way we don't have to all use a GitHub, account and fork and clone down a project. We can just get immediately down to work. So let me make sure I have the correct app here. Hope this works. That would be annoying if it did not. Let's see. Oh, perfect. There we go. Excellent. If you're able to access this, feel free to give me a thumbs up. And if you have questions along the way, definitely ask questions, because I know this can get fairly technical, what we're going to dive into here, but hopefully this will allow you to see kind of the thought process behind what happens when you write a test. So let's take a look at this app. And I'm going to close this down for now. Take a look at this app. It's a really simple app. If we go to app.js, we have a component. It's called list users. We go into list users, we open that up. List users is a component, and it has a custom hook, use list users, that does some fetching of data. It fetches some data from an API, and then it fetches data from the API, then it sets it, and it returns some helpers for us to filter through the data. This is actually not so important to know. You actually don't need to know much about the implementation of this. And that's one of the beautiful things about writing tests, is that you are going to focus more on the outcome. What should happen when a user does something? For example, we might want to test that, when you come to this app, we have, user Brett is in the DOM, that it's actually visible on the screen. I'm going to filter this list, typing BR, and you see it filters as well. And, pretty simple little thing, right? But it does a few interesting things. It, one, grabs some data from a URL, and then two, listens for, a user event, a typing event, and we type and we filter, and we get this list of users to filter down. Now, this is using React. And before we get into the React implementation of how to write a test, let's look at the most basic test you could write. There's a utils file, which I'm sure you've seen in most apps that you've written. There's some helpers file, utils or helpers. And these are typically very basic JavaScript functions, which are the easiest to test. Now, we're going to start by writing a very basic unit test. A unit test tests a function, for example, tests a small unit of your code, right? And what it typically does is it will test, hey, this input or this unit of code, this function, given this particular input, should give me this expected output. Super simple. And the reason why you want to do this is kind of some of the ones we went over is because you want to make sure that, hey, does this function actually behave in the way I expect? I have a pretty simple function here. It's called isPalindrome. All it does is it takes in a string, it reverses it, and it checks if that string is equal to the reverse string. Super, super basic, right? Let's go to the spec file. Now, if I was starting this from scratch, I'd have to add Jest. Jest is probably the most popular unit testing library that's available for JavaScript developers, and it's been added here as a dependency. If I go to package.json, you can see that I've had to add a few things in here to support testing. The first thing you want to do that we really need for this test is Jest, which is in here somewhere. Jest. Okay, I think this is a code sandbox thing, but usually you'd have to add Jest. I think it ships with testing library, but Jest is available in this particular project, which allows us to write code like this. We have a describe block and we have an it block, and we're going to write some tests on our own too. In fact, I'll just erase this and we'll start from scratch. So someone give me something. We saw this code is palindrome, right? It checks if something's a palindrome. Super simple. So we import that function. What's a good test you think I could write for this? Someone in the comments or yell it out if you want. What's the simplest test we could make for this?
What?
Sorry, what? Is it a string? Are the first and last character the same? Let me ask you this. What should we want to test that is palindrome works? How can we determine is palindrome works? So like, what's a way you said the first and last character are the same, but let's see what this actually returns this. This returns a Boolean. This returns true or false. Yeah, I think this is, I'm going to thank you, Meredith, and Tara, and Hope as well, is the input field present on the DOM. So actually, we're not testing anything DOM related yet. We're going to get into that in the next more complicated test that we're going to do. See if and returns Dina. Okay, cool. I think people kind of got it. I'm going to go with Meredith here. Thank you all for the input here. Pass the palindrome and make sure that it returns true. I'm going to write that here. I often like to start off by just saying, hey, what am I testing? What's the point of this test? And I just write it in plain English. So the way we start off a test with Jest is to have a describe block. Describe will typically, it'll say, what are we testing? It'll say, it'll just be a simple like describe. And then in this case, what are we describing? What are we testing? We're testing described is palindrome. This will take a callback function. So we have a function here, arrow function. And in here is where you'll write a series of smaller tests, these logical unit tests, right? And they typically go like this. What does it do? And you've said this here, Meredith, I believe. It takes a palindrome and makes sure that it returns true. And we write what it should do, right? It returns true if a word is a palindrome. Okay, now this takes in a callback function as well. And here's where your actual test takes place. What you do is you have an expect statement. And what do we expect? We expect is palindrome with, I don't know, someone give me a palindrome we can check. What's a good one? And is not a palindrome. Hannah, there we go. Hannah, race car. Haha, race car. Okay, race car. And you can have as many of these tests as you want. So we can I'll put race car, also make one, and I'll put Hannah in there as well. And what do we expect? We expect this statement here to be what? To be true, right? So we put to be true. Now, I know this off the top of my head because I've written so many tests. And you may wonder, well, how would I just know to put this here? And I would suggest you go to the Jest documents. The nice thing about Jest is that everybody uses it. So if you're on Stack Overflow or asking ChatGPT, you'll typically find how to test something. This is the simplest type of test. You give it an input and you have an output. You say, does this input equal this output? So for example, if is palindrome returned like a number, we might say to be, 4 or 5. Super simple test. This is the best way to start off with. Will this session be recorded? I don't know. But I do have a lot of this already recorded in another like free guide that I have that I'll share with you all as well. So if it's not recorded, I'll share that as well in the comments. Let's take a look at these tests. So we go here and we see, oh, good, this is passing. We see this is passing. We have a test that's not passing. That's okay. We're going to fix that one in a bit together. Cool. Now, I do see an issue with this test, though. Now, let's try to test something a little less obvious. This is where the power of these tests really come in handy. Now, it returns true if the word is a palindrome, but what about this? Would this work? Because like Hannah is still a palindrome, right? It's just not, it's just one letter is capitalized in the front and the other one's not. To me, I mean, I think that's still the definition of a palindrome. These tests, by the way, if you're using Code Sandbox, it's a little finicky, can take a while sometimes to run. I don't know why. Kind of annoying, but hey, it's free, right? Good place to start, I'd say, if you're writing tests. Plus, it's just easier for us all to work together. So I'm going to expect this to be true, but I don't think this test is going to pass. And this test is taking too long, so I'm going to refresh. Uh-oh. And this is the output you'll get when a test is false. It says, wait a second, we expected this to be true, and it's not, which is good. This is what you want during a test. And in fact, this is how most people that follow test-driven development work. Test-driven development would be if we wrote these first, and then we went back and wrote the code to make these tests go green. So you start with red, you say, hey, it doesn't work, and then you fix it. In this case, we need to fix this. So how could I fix this? We could say string dot to, lowercase or something equals dot to lowercase. And then I think we'll be in a good spot. Hopefully this will pass now. And now we've caught a bug that may not have been caught. And we can, the test took kind of an edge case. This is, again, a contrived, not very realistic type of case. But this is the whole point of a test. You write tests, you test things that aren't immediately clear or easy to reproduce. And you can have a test that does that for you. Then you can update your code to actually satisfy the test cases, which I think is always helpful. If nothing else, it gives you a lot more confidence that what you've written actually works the way you say it works. And there are ways to programmatically test like different scenarios. So Jest offers a code coverage tool out of the box where it can actually run line by line through your code and make sure that you're actually testing things that you think you're testing. I don't have time to show that today, especially within Code Sandbox, but running the coverage tool is very simple. Look at that. Our tests now pass. Great. Now we're going to get into React Testing Library. Now, React Testing Library, anybody here used React Testing Library or heard of it? No? Yes? Maybe. Yep. Nope. 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 All good. Yep. No. Okay. Okay. I'm always curious because yes. Okay, yes, a bit. Yep. React Testing Library, I remember when it was not a thing, and the power of React Testing Library is that it does not test the internals of a React component, right? So when you write a React Testing Library test, in fact, let's just look at one together. We're going to ignore this one for a minute. We'll get back to that in a second. Same rules apply. React Testing Library offers you a couple methods, render and screen. These are the two most common methods that you're going to be using when you use Testing Library React. This also ships with Create React App. It's like the official tool for React. They say they recommend you use this above everything else. InDesign used to be a tool people used, and that's been kind of deprecated, not really used much anymore. This one is basically a way for you to interact with the screen in the way that a user would. So for example, if we go to this allow recording, if we go to this app right here, what is the, let me ask you this, what is the point of this app? Like what is the main feature of this little app that we have here? You can type it, but like, what is the thing this app does? Yeah. search for a user, filter by a user. This is important because when you're writing a React testing library test, it's important that you're thinking, what is important to test, first of all? What do I care about? You know, do I care that users is in the DOM? You know, probably not. Kind of a useless test. Do I care that you can filter? Yeah, absolutely, right? Because that's kind of the main feature of this. So there's a bit of like thinking of, okay, what do I really need to test? What's going to make me feel more confident? What's going to make my team feel more confident? What's going to make sure that when I get this deployed into production, that there isn't some weird case that someone says, wait, you didn't check that thing? That's always embarrassing when you release code and someone's like, oh, you didn't check that one scenario? And you're like, oof, I did not. And then you know, it's not fun. I've been in that scenario many times, unfortunately. Writing tests is one of the easiest ways to ensure that you don't fall in the trap of thinking, oh, well, it worked with that one simple case I tested. And we're going to see here a case where I did not have a test that's not working that we're going to need to fix. So when you write a React testing library test, what you'll do is you'll render the component. In this case, and you may be wondering, why are you rendering app? Why don't you just render list users? Well, the nice thing about React testing library is when you render app, it renders everything in it. What it does essentially, for all intents and purposes, it renders this entire set of components. Because we don't really care about testing a certain component. We care about testing the whole functionality of this larger component here. We care that when you filter on something, that it works, right? That's what we really care about. And we see this is a fairly, you know, I've made this a little more complex on purpose because I don't really want you to worry too much about how this is working. I want you to worry about what do we want to test. That way, this is the nice thing also about React Testing Library. You don't need to know the internals of the application. You don't need to know exactly how it's working. You just know that you're trying to test some feature, right? And you do see there's one interesting thing here. We are using a window fetch. Can anybody think of the problem of maybe testing a component that makes a third-party API call? Let's say this test was running 1,000 times a day, which is not unusual, right? Like if you're a really big company, you could have a test potentially running 10, 100 times a day. What are some of the issues you could think of with having a test that actually fetches some data from a third-party URL, third-party API? What might you run into if you did that? Might be rejected. Yeah, you can't. Yeah, sometimes there are charges. It could be rejected. You can't always count on it returning the same data. For example, maybe, you know, they say, hey, you've been rate limited. You know, it's no longer working. Response doesn't come back. Your tests become brittle, right? Because at this point, you're relying on a third-party API, and you're thinking, well, you're running this test 100 times a day. You probably don't want to do that for many reasons. There are many reasons you don't want to do that. Now, there are some people that say, oh, you know, I do want to actually hit this URL. That's fine. That might be better suited for an end-to-end test. An end-to-end test, which is out of the scope of what we'll talk about today, is similar to what we're doing with React Testing Library, but it's actually, it's like programmatically opening up a browser and then clicking on your app the way a user would. And it actually does that by opening up a headless browser or a browser without a UI associated with it or a window, and like literally going around clicking on elements through like a computer program and then seeing if it works. Integration testing is actually a little different. So end-to-end, there's actually a testing pyramid. End-to-end testing is the smallest piece of the pyramid. Integration testing is in the middle, and unit testing at the bottom, the largest part of the pyramid. So unit testing would be like what we saw with utils, where you're testing literal small units of code. Integration testing would be testing a composition of code, like composing multiple functions together. And essentially in a React app, that's what you're doing, right? When we're testing app, we're not just testing app, we're testing list users. We're also testing use list users. So we're testing a series of functions that are housed within app.js. That's a great integration test. And end-to-end tests are really expensive because you are going to be making real API calls. They're not very reliable. So that's why they typically are always at the top of the testing pyramid, the smallest part of it, because you don't want to rely on too many of those. Integration and unit testing is what you're most likely to come across as a developer. So let's take a look at this test. And we've just identified why you probably don't want to really, let me go back to that test, why you don't want to really hit this API. So when I think of writing a test, I think of it in a couple parts. I think one, set the stage, mimic or mock third-party dependencies. In this case, you probably already tell what is our third-party dependency. We don't really want to fetch data, right? For many reasons. It might come back different each time. If it comes back users Brett one time and users Bob one time and users Amanda one time, it just returns random data, that's going to be really, really hard to test. So what we do is we're going to mock out the fetch function. If you were using AWS or Axios or whatever, you would do something similar. You don't want to get, I don't like to get too caught up in the details of what's happening. I like to think high level. High level, I want to set the stage for me to test some things in this app. So first of all, I've imported some things here. This is boilerplate code, the code you're just going to write every time. You're going to import render and screen from testing library. We'll get to user event in a bit. This again is boilerplate. This is just stuff you need to set up that test. And then importantly, we import the thing we want to test. And we follow the same pattern. We describe the component. We say, hey, we're describing, this is the top level test. We're describing, in this case, app. That's the thing we're going to test. And the it blocks are going to describe particular situations we're going to test. So before each test, this comes from the jest library. It's, you know, it's a global method. So you don't need to say just before each. It just kind of magically appears, right? You get to say before each. So this means before each test, I'm going to say global, and global means like just get the global version of fetch, you know, and here we're saying window.fetch, and this runs in a Node.js environment. So we're saying global because the window is only available in a browser environment, but global is what we're going to call it in this environment, which is the Node environment. Again, not super important that you like understand all that part. The important part is what's going on in here. We're going to mock this out. We're going to replace the real fetch with our own version of fetch. So fetch, anybody know what are the two things returned by fetch? If you have that memorized or kind of know what fetch returns. We can look at it here as well. You call fetch and it returns this, right? Yes, it returns one promise, right? And then it actually returns another promise, which has always been a little confusing for me because you use like Axios or something like that. You just say axios.get and then it returns some data. But this returns one promise, res.json, which is another promise. And then from res.json, then you finally get something you can use. So in order for us to mock this, we first say we'll have just promised resolve. We resolve an object that has a JSON method. And the reason why we did that is because if you look here, oops, not here. What does this return? It returns an object res, and res has a JSON method. So we're just mocking this with the same shape we expect. And then we say, what does JSON return? This is where we get creative. We know in list users, for example, we expect a users array with a bunch of objects, and these objects have an ID and a username, right? So and if I didn't know what to expect in here, I could just go to this thing here, and I could check out what does this API response look like. If I really wanted to, I could just copy this whole thing. I could copy this whole thing and use it in my test, but we don't really need to because we're really only using a couple pieces of it. So instead of having all this code, I'm just going to add the pieces that I know that we care about in this test. But there's nothing stopping you from just like literally copying and pasting this into your test. So we go back here. We are setting the stage here. We've set the stage. We say, oh, cool. We're going to return 3 users, Bob, Rob, and Sally. Great. Now, the first test is it displays a list of users. We await, now we render the app, and from render app, render is a method that renders it, you know, as it kind of sounds. And then it exposes a few different methods that come back. We have find by text, get by text, There's all sorts of different ways for you to basically inspect the DOM and look at things by text, by the user role. In fact, there's all sorts of stuff here. You see all of it. Get all by text, get all by title, get all by alt title. There's so many things in here. The ones that you're most likely to use are get by text, get by test ID maybe. And let's see what else here. Find by text. Now, the one interesting thing about this one is it's asynchronous. And why do you think I have to make an asynchronous test for this particular component? Anybody got any guesses of why I've made this async instead of not async? In fact, let's just move that, move that. Let's see what happens if I don't make it async. Ruh-roh. Oh, it still passes actually. No, it doesn't. Good. It filters a list regardless of letter case, and it displays a list of users. To mimic API, yep, you got it. You got, yes, excellent. We're using a promise here, right? So in order for this promise to resolve, it's important that we, one, make this asynchronous so we can actually await finding the text. Because if we don't actually, when the app first loads, there will be nothing that says user Bobberoni, for example. We'll have to wait until it actually resolves to find that user, because we're mimicking that same promise chain that's happening in use list users. So now we await find by text. We say, okay, we're going to find this by text. And if we go to the browser, we know that we're going to find something like this, user Bobberoni. And that's because here we put Bobberoni. If I change this to Bobbert, then this test will break. Also, always a good idea. You want to make sure that, you know, you're testing not only the happy path, but the not so happy path. How do you make sure the test works? And look in here, this is really useful. It actually gives us a printout of what's going on in the DOM. So we say, oh, we have a user Bobbert, but we don't have a user Bobberoni like I thought. So I'll change this to Bobbert. And we expect this to be truthy. JavaScript's a little weird, right? What's a truthy value? A truthy value is something that's not null, not zero, not undefined. So when you find this, in fact, I encourage you to do this, is this console log. What does this actually return? What does this return? Let's see. We can look in the console here and see what exactly is coming out of here. This is also a good way to debug your tests. If you're trying to figure out, like, wait a second, like, what is going on here? I will spoil the surprise. This returns a DOM element, returns an object. And so an object is always going to be truthy. Now, if we couldn't find it, it would return, hey, I didn't find this thing, I'm returning undefined. That's going to be falsy, right? So we expect to find something, essentially is what we're looking for. The other way to do this is to be in the document. We'll look at that. And this is what actually is returned from the console log. Okay, now let's take a look at our next test here. And I don't expect you to really, you know, fully get these tests at first. This is a lot going on, honestly. And the only way you can really get better at these is to write your own tests. But this should get you at least started. So this is, I encourage you, you know, once this is over for sure, like go in here, update these tests, change around the names, change around other things, use a different API maybe, and see, can you get this to work by doing that? That should get you at least started in a good way. Writing the test, writing these first tests is usually the hardest. Before we get to Q&A, I want to go through one more test, and this one is a little more difficult. This one is actually the most important one. As people said, the whole point of this app is to actually filter the list of users, right? That's what we actually care about. So once again, we render the app. We get the user input. And so we get the user input by capturing that element. We say we're going to get the text box, and it has a name of user filter. And I've done that by, this is something I just had to look up, by the way. If I go to app.js, list users, we see that we have a label of user filter, and we can identify that using screen get by role. Get the element by the role user input. Now we kind of walk step by step. So what we're going to do is walk through the user flow. What do we first need to do? Get the input element. What do we after we get the input element, we probably want to actually, use it. We want to type something in it. Type a name to filter by. Once we filter, what do we expect to be true? Like if we go here, for example, and I filter by ANT, how can I tell it works? Like what on the screen lets you know, hey, this is working? Feel free to drop it in the comments. Like nothing mind blowing, but just generally, how do you know, like as a user, nothing about code? The other names aren't there. Yeah, exactly. If I type Delphine, so the other names are not there. That's a good one. What about, I like to look at the length as one way too, which we'll see. That's what I chose to do, is you can either look for the disappearance of things, which is one way to do it. You could say, hey, this should only have this particular name. It should not have other names. That's one way to do it. I chose to go the route of checking the length of it. Now that is maybe not the best way to do it. So I encourage you to update this test to maybe do a little bit better than I did, because if this didn't work, you could potentially have one incorrect name if the filtering didn't work correctly. So you should probably check that the correct name is there and that it has a length of exactly 1. That's what you should check for, or however many ways that you want to determine that this is working as expected. So we get the user input element, we type a name, and here is where we make our expectation. What is expectation? We get the list of elements. So this is an interesting variation of find by text. We find all by text. It means we get a list, and we can even console log that out to see what that looks like. And this test is breaking, and maybe you'll see why in a second and how can we fix it. But let's see what's in the console. Go to tests. Come on, Code Sandbox. Okay, console. Hey, what the heck? All right, don't know what that's about. Users, I need to find element with the text user. Oh, and I wonder why, because we're filtering by Bob, but let's see if we filter by Brett. Do you notice something? This works, but this does not. What is the issue we have here? What did I not support here? And this is a good check. Capitalization, exactly. So this has caught an actual error. In this case, we should be able to filter by Bob, cap lowercase b, but we're not. So now we can go in here maybe, and we can do username dot. We can do something like this. Const val equals I'll just make this real messy, but we can just do this. Dot to lowercase includes val. We'll just make this const lc val dot to lowercase. We'll change that, and we'll change this, and then we should hopefully have our test pass, and we'll see if it does. And username dot to lowercase. Okay, so now let's see if this affects our test, and I hope it does. Look at that. We've just passed all the tests. We found an issue, and we've corrected that issue. And now we can go back in here, and we can ship this out and say, okay, now we feel confident that this works as well. Now, as a little bonus, I'd say to do, how can you ensure that the correct name is in the DOM? What about erasing the input field? Do all names show up? And then lastly, one thing we didn't test, which is important, this is a good test that you could do. Test for the error scenario. What happens when the API returns an error? This is the great thing too. We didn't go over this part yet, but I'd encourage you to do this on your own. These are some great additions to the tests we've already written. The nice thing about having access and mocking out fetch is that you don't have to resolve. You can do a promise.reject. And the way you do that, I won't go into the whole thing because I want to leave some time for questions, is to do something like this. You could just take this and put it in here somewhere. I'll blow up this test right now, actually. And we'll just do promise.reject. And guess what? This test will no longer work. So this is the great piece of having this, because it'd be really hard to test. To test an error manually would be very difficult to trigger. To test it here is trivial. You just simply reject from promise and you're done. Now you can test the error path and make sure that, hey, do we actually display the correct error when there is an error? And you can be kind of confident now that that works. Taking way too long to show, but just trust me. Just trust me. I know we covered a lot of ground, so I'm going to stop sharing, and I've talked for quite a while, and make sure that we give people time to ask questions. I'm going to stop sharing there. And while I'm going to also get a little thing, what's it called? Sheet for you, a little, it's a sheet that has some access to some of these testing things, and it goes to more in depth with Jest and how to set it up from scratch, which I think you might find useful. But questions, yeah, any questions from people or things they thought were interesting, weird, didn't get, general questions on testing? If not, that's okay too. And I'll just say this, as people either think of questions or if they don't have any. I'm an engineering manager, which means I look at a lot of portfolio projects and a lot of take-home tests. I'm not a fan of take-home tests at all. I'm really not. I think they take a lot of time and they can really drain you on like a weekend or whatever. They always say they take 4 hours and they take, 3 times as much. It just universally, I've never seen anybody really complete a take-home challenge in the time that's allotted. If you're going to spend that much time doing them, number one way to stand out is writing a test. I worked with a guy and he wrote a test. He works at Calendly now. And that was the difference between getting invited in for the interview and not. They said, you're one of the only people that's written a test. No one writes tests for take-home assignments. This is by far and away the easiest way to stand out, along with documentation. Doing these things, even a very trivial test, will just set you apart. So I think it's totally worth your time to know, and it's something you're going to come across on the job. Meredith said, you had 100% test coverage is unnecessary. How do you judge what is the proper amount? That is definitely one of those issues that people will have lots of fights about. I have now gone, I used to think that having really high test coverage was important. Now I've changed my opinion. I think it's important to have it on certain files. For example, we have an e-commerce app, and if you enter your credit card information and do some stuff and add to cart, these are things that cannot break, or else we're in a very not fun position. So in my opinion, I have just 100% or 90-something%, some arbitrarily high number for that particular file or those set of files or whatever. And that way I can ensure that this critical piece that cannot break does not break. For other pieces, it's a very subjective. And then ultimately I kind of leave it up to developers to think how, do we need to write something for here or not? And for things we know that can't break, we have very high coverage. My rule of thumb. Okay. Thank you. And I'm going to put this in the chat here as well. You can go check out this document I have that has like access to other testing things. What are the trade-offs with different testing frameworks like Jest versus Mocha versus Chai? They essentially do the same thing. I've used them all. And I think actually, I forget if Mocha, it's so funny. They're all so interchangeable. I feel like that I couldn't even tell you the difference between one or the other. And yeah, I don't think there's I think it's fairly subjective. Now, React testing library is less subjective. It used to be the only game in town. Now you have stuff like Vite, if I'm pronouncing it right, VITE. VTest, they offer a great alternative to React testing library. But Jest, Mocha, Chai, if you're a JavaScript developer, I would probably just go with Jest because it's the most ubiquitous one you're likely to come across. But it's up to you essentially. All good. Is there an alternative for Angular? Oh man, I know that I haven't worked on Angular for a very long time. And I know there is, and I couldn't tell you. The nice thing though is I mean I learned how to test writing Ember and Ruby, right? Completely different frameworks than React, right? And I just applied that the same high level concepts I learned in Ember, I just applied to React. It didn't matter. I've used Ember, whatever the testing library was for that at the time, and then I went to React. We were using Enzyme, and then I went to now React testing library. And honestly, if you get these high level concepts correct, it's more of an implementation detail. Because nowadays with ChatGPT or Copilot, as long as you understand, I need to mock something, I need to understand what behavior I need to test, and I need to understand what are some of the edge cases and how to figure those out and identify those. The rest is implementation, which is still difficult, but a lot less like, I'm not like so into like this particular framework for this one or this one. I think, what do I want to test? How do I want to test it? What should I mock out? Yeah, good. Thanks for the questions. Cool. I'll try to pin this in here. I don't know if I can, but
Brian, I just wanted to jump in again and say first of all, thank you. That was amazing. I'm not a software developer, and even I enjoyed that talk and it felt like it was really clear. And for those that came in late, I just wanted to reiterate how important testing is. I do exit interviews with all of the apprentices that we have placed on site. I was just speaking with one of our Amazon apprentices who recently converted, and she said the one thing that she needed more of and didn't get enough of in her boot camp and her training was unit testing. And I've heard that from several other apprentices going through different cohorts as well. So this really is a way, as Brian said, for you to immediately stand out, to feel like you have an edge in the job search and interviewing process. And it's definitely a skill that is not going to sit dusty on the shelf. This is something that you'll be using probably every day. So thank you again so much, Brian. I will mute myself for any additional questions, but just wanted to say thanks so much. And thank you everyone for being here, for taking the time and putting in the effort and energy to continue to build your skills, boost your portfolio, gain more of that edge, as you go through the job search process.
Yeah, seriously, thank you all for showing up. I know it's like lunch or whatever time, whatever place you're at, appreciate spending this time. A couple last questions. Looks like, how many expect statements should a unit test have? As many as you want. No hard and fast rule. Teams will have different norms and standards. For me, I don't care as much. Unit tests are one of those weird things where you can kind of get away with breaking a little bit of the rules of other places in the app that you may not. Like there's typically less rules I notice around tests. As long as they work, people are typically happy. Okay. Cool. All good. As many of you know, I'm on LinkedIn. I hate to say I'm really pretty swamped with inbox stuff, but if you have particular questions, I'm always like happy to, to try to answer. Just started, all this is new for me. Cool. Any advice for bootcamp grad, people from non-traditional backgrounds? My very generic advice, super generic advice: build stuff that you're proud of, that maybe solves a problem for you or your community, or somebody that can solve a problem and do it as much as you can without relying on a tutorial, because it's going to be something interesting you can talk about and deploy it. That is going to be the number one way to upskill yourself and learn without training wheels. And that, I think, is going to be your best bet as far as like something practical you can do. Cool. Yeah, thank you all. This is a lot of fun. Always a little nerve-wracking writing tests in front of a lot of people. Hope you all enjoyed it. And yeah, feel free to play with that sandbox, and hopefully you can take it and make it your own. Yeah, it should be. Yeah, I think more boot camps are going to start introducing it.